going to talk about how we actually deployed these things at Comcast, but I'm getting ahead of myself. Let's build a workload. Okay. No matter what you're doing in AWS, it's extremely likely that there's some data in S3 that is part of what you're building. So we have an S3 bucket. Now, as you know, if you've even spent a few minutes building on AWS, that a resource exists inside an account in AWS. Now, account isn't necessarily in a one-to-one relationship with customer. Rather, account is, you can think of it as a tenant. You as a customer might have multiple, maybe many AWS accounts. But here's one that you do have, account 111, and your S3 bucket is in that account. Well, of course, data isn't very interesting until you're doing something with it, so let's keep building our workload. Let's say we'll keep it really simple. Let's run, we're just running an application of some kind on an EC2 instance or a Lambda function or ECS or EKS or whatever you want. But it's your application is reading data from this S3 bucket. This is your workload, and actually, you can do a lot of things with simple workload shaped this way. All right, but we're here to talk about, this is an IAM talk, so what do you have to do with IAM for this workload? Well, okay, because if you've ever tried this, you see that you need to do this. Your EC2 instance or Lambda function or what have you has an IAM identity associated with it, with the credential sort of seamlessly delivered to the compute. This is called an IAM principal. And before this EC2 instance can read the data from S3, it's going to need some permissions to do that. So over here, you can see that we've written an IAM policy. This is a good, well-configured IAM policy for what we're doing here, assuming that the instance needs to read the whole bucket. So we've given the instance permission to read the bucket, and everything works. This is great. Okay, but in the real world, things often get a little bit more complicated. There's a lot of things you could do with that application, but let's make it a little bit more interesting. Most every customer of AWS, once they get past, a little bit of, experimentation by an individual, is going to have more than one AWS account. Some large customers have thousands of AWS accounts. And again, these accounts they're a useful security boundary, they're a useful blast radius boundary, a useful kind of unit to contain the resources associated with one workload. So as soon as you start working in an organization that has multiple AWS accounts, you're going to find that pretty soon you have a workload that's going to look like this. For whatever reason, the compute is in one account and the data's in another account. Now, there's all kinds of legitimate reasons why you might need to do that. Maybe that S3 bucket is actually data shared across multiple accounts, right? Maybe it's some shared configuration, something like that. So you're going to have the compute over in one account, reading the data from the other account. Once again, we have that very good, very well-written IAM policy on our EC2 instance says it can read that S3 bucket. But of course, if you think about that one a little intuitively, right, that shouldn't work, right? The S3 bucket is now owned by a different account, which is a security boundary in AWS. It's a boundary of ownership. And nobody in that account said anything about whether this access should be allowed. This isn't sufficient. What you have here isn't sufficient to make this workload work. Okay, well, again, if you have kind of some 300 level knowledge of IAM, like I assume many of you do, you know exactly the solution to this problem. We're going to write a bucket policy, and basically an IAM policy that's attached to the S3 bucket. And this IAM policy, if you look at it, you see that it is saying that account 1 can read the objects in this bucket. Okay, so now you've got account 1 saying this can happen, you've got account 2 saying this can happen, and those of you who know IAM know that this workload is going to work now. And what we have here is a well-configured AWS workload, well-configured policies in both places. This is a good application that you might write. Okay, but let's think a little bit more about that bucket policy that allowed access from outside the account. We had a nice least privilege policy there. Who wrote it? Well, who wrote it? Somebody wrote it, right? A cloud operator of some kind. Now, of course, you might have CI/CD pipelines, infrastructure as code. You might have automation that this goes through. So there may be a much more complex and guardrailed setup on this, but ultimately, somebody put that policy there. So I have this operator up here. This operator, his job is to write these bucket policies in account 2. He, has control over the buckets in account 2. And, just to make it real clear, this cloud operator, if I look at the IAM role that he gets to work in, he has this put bucket policy. He's allowed to assign policies to S3 buckets. Okay, so what does he write in there? Well, hopefully, he writes that policy we saw in the previous slide. That's a good policy to write if you're trying to share it with account 1. But the truth is, with the put bucket policy permission, he could write anything in there. It's simply a document, and he gets to write the contents there. So, you might start wondering, how do we make sure that this cloud operator in account 2, who's responsible for this bucket, is writing a good least privilege bucket policy on this bucket? How do we know that he's on top of what he's doing? This problem gets a little bit more interesting when we have lots of accounts and lots of buckets and other sorts of resources that can be shared across account, and lots of different cloud operators that are respectively empowered to write these policies. And, once you have a lot of people doing a thing, you know that there's going to be a pretty wide range of skill set here. There's going to be people who are pros at writing IAM policy and people who are just learning how. Okay, so what do we do about this? Of course, it's important to us to make sure that all of these bucket policies are reasonably well configured for whatever it is they're doing. But even more important than that, the most basic need here is something that we at AWS for the last 6 years or so have been calling a data perimeter. This idea that at scale, across all of these accounts, and if you have many accounts in AWS, they're probably an AWS organization. That's an organization of accounts. Across all of these accounts, no matter what the respective skill sets of all of these cloud operators are, we are keeping outsiders out of the data. You want it to be that no matter what these operators are doing in these buckets, whether it's maliciously or more likely accidentally just due to not having the right skills, you make sure that the buckets are not accessible from the outside. And that is exactly what we are here to talk about today. We are going to solve this problem here today with a feature called resource control policies. So, I'm going to start by kind of explaining how resource control policies fit into this story that we started. We'll finish the story and talk about how you get there with resource control policies. Because this is a deep dive talk in IAM, I'm going to tell you I work on IAM. I love IAM. It is my favorite service in AWS. And I'm going to tell you a little bit about just how it works, like what is actually going on in IAM. You don't really need to understand that to be effective, but it can be very useful in understanding why this and that does and doesn't work. I'm going to give you a few sort of cheat sheets for the common patterns that we see being effective for customers. And then the best part of this talk, I'm going to have David Hockey, who's here from Comcast NBC Universal, talking about all of the practical considerations as they roll out resource control policies over a very large AWS environment. All of the practical considerations to think about. The details here are fascinating. So that's actually the part that you came for, and it's going to be fantastic. David is, we've worked with David on the IAM team, have worked with David for many, many years, and have gotten a lot of deep insights into how customers really do think about IAM. So you're in for a treat. This talk is by builders, for builders. Okay, let's go back to our story, which I kind of ruined already because I told you that resource control policies is the end game of this story. But let's go back to the story. Lots of accounts, lots of cloud operators. They're writing bucket policies, but I don't actually know what they're writing. So before resource control policies, and it continues to be the case that there are some solutions to this problem. One solution is this. Well, hey, we have all of these cloud operators with a diverse set of cloud skill sets. We're not sure we trust each and every one of them to write these policies correctly, so we're not going to. We're going to take away that permission from all of them. We're going to make them go through a single arbiter of good taste in IAM policy, someone who really does know their IAM. And this is going to work. And you know how this this operator up at the top really really knows her stuff in IAM. She's wearing her hair up. Yeah. Okay. So she's they all go through this single reviewer. If this sounds to you like a bottleneck, if this sounds to you like not quite developer freedom, yeah, you're right. But hey, it'll be better than having all of these people write it individually, maybe. Okay, what are some other options that we had and continue to have? Well, we have in the specific case of S3, we have S3 block public access. This is a feature that we've had on S3 since 2018, and since 2023, it's actually on by default, so you probably don't even need to think about it anymore. But this is a great automated reasoning, mathematically provable technology that we have on S3 buckets to make it actually impossible to write an inadvertently public policy on the S3 bucket. So if we have that on all of our buckets, then the worst kinds of mistakes can't really be made anymore. And that's good, except, it's out there. It's on by default. You're probably using it whether or not you're thinking about it. And that helps me from some of those use cases of the data perimeter. But, what if one of these cloud operators somewhere is writing the policy allowing access to an account, but maybe misspells the account, fat fingers it, gets it wrong, maybe even maliciously puts a different account in there. Well, that's not a public policy, so block public access not going to help you there, even though it's so useful in general and it's just on by default. Okay, what else could we do? Well, we've been talking about the preventive realm. Let's talk about the detective realm, right? Any well-configured AWS environment from a security perspective is going to have some detective controls on it. We have a great feature called AWS Config. AWS Config is a great way to get a map of all of your resources in AWS, and it also has this feature called rules. So these are change-triggered rules. We have some that we offer out of the box. You can implement your own, anything you want to do on Lambda functions. They can alarm, they can remediate, really anything you can do in a Lambda function you can do from these rules. So we could write some rules that looks for any changes to S3 bucket policies and scans them and just make sure that they don't allow in any accounts or organizations that we weren't expecting. And that works quite well too. Of course, we've had many customers observe to us over the years, and this makes sense, that preventive controls are always better than detective controls because a preventive control prevents the misconfiguration from being made in the first place. So that brings us to what we launched, it was about 6 months ago, a feature called resource control policies. So this is a feature of AWS organizations, and this is a type of IAM policy that you can apply to your whole AWS organization that attaches to all of the resources in it. So this can create a protective boundary around all of your resources. And if you want to declare that outsiders can't get in, you can do exactly that in a preventive control and resource control policies. And I'll show you how that works. So they can be applied to the whole organization, to organization units, to accounts. That's going to figure into David's part of the talk. He's going to talk about how he makes use of that. If these sound similar to a feature we've had in AWS organizations for quite some time called service control policies, you're right. It's basically, service control policies was basically this feature but applied to all of the principals, all of the identities from the organization. This one applies to all of the resources. So it's a very efficient way to keep outsiders out of all of them. So that is what we're here to talk about. Resource control policies. Resource control policies are straightforward, they're scalable, and they're preventive controls that are going to be a linchpin of your data perimeter strategy. As of today, resource control policies are supported by these 5 AWS services. You can see S3 is right up here, but also a few other resources in AWS that our customers have told us is a priority. What all of these resources have in common is they're all resource types in AWS that are by design shareable across accounts. They all have a lot of use cases that make it very compelling for them to be used across accounts, like a key in KMS. In some cases, you want to allow another specific account to decrypt using the key. So customers told us that these are the resources that they tend to share, and therefore these are the resources that they most want resource control policies applied to. Of course, we're working on getting coverage for a much wider set of AWS services, but those were the priorities. Okay, so that's why you might use resource control policies, is to create that scalable, straightforward perimeter. I'm going to tell you a little bit about how, just in the IAM world, how this exactly works. So let's go back to our workload in 2 accounts. And if you remember, we said that we had to write 2 policies here. We had to write one policy on the principal, on the caller, that IAM role on the EC2 instance in account 1, and then another one on the S3 bucket in account 2. I sort of mentioned offhand that, like, hey, it's intuitive that you should need both of these policies, and maybe it was intuitive to you. But I'm going to be a little bit pedantic about, like, exactly why that was needed. Okay, so an AWS account, I've sort of roughly defined it as a unit, an ownership construct for resources, a workload. I've described it in all of the following ways. From an IAM perspective, it's an issuing authority for policies. It is a thing that owns identities. It's a thing that owns resources, and it's a thing that is authorized to issue policies for the things in its account. So we have 2 issuers involved in this request. There's a caller from account 1, and there's an S3 bucket in account 2. So we actually have 2 issuers here. And if we have 2 issuers, that means that each of the issuers is going to have to say okay before the request is allowed to proceed. And what that means, technically, from an authorization perspective, is we're going to do authorization in 2 separate rounds. First, we're going to authorize our request against policies issued by account 1. If we get stuck here, we don't continue. Then we're also going to do a separate round with different policies from account 2. We got to pass through both of those. Okay, so we're going to start with account 1. Right, so this one, the principal policy by account 1, the bucket policy by account 2. Let's start with account 1. Okay. Now, if you remember, we wrote a very nice, well-configured IAM policy. We attached it to the principal for that EC2 instance, the IAM role for the EC2 instance over in account 1. That means that policy was issued by account 1. So in our first round, and I'm ignoring, if you're an IAM pro, you know that there's things like VPC endpoint policies and other things in play here. Don't think about those right now. We're just going to focus on the principal and the resource. So over here, what policies is account 1 issued? Well, it's issued this policy, and probably a lot of other ones that are irrelevant to our request, but we're going to focus on this one. And our authorization system is going to match the request that's being made and all the properties of all of the things in the request against this policy. And it's going to succeed, right? Because the bucket being requested is indeed the object being requested is indeed something in example bucket, so that's going to succeed. In fact, because we're here to talk about organization policies, let's make this side a little bit interesting. Let's say that also issued by account 1, or technically by the organization that owns account 1, also issued in this account is a service control policy. And I'm showing you a service control policy here. And, if you're an IAM person and you haven't seen one of these before, you're getting a little bit itchy from that first statement, allow everything to everything. But you should know that a service control policy is not actually a kind of policy that can grant access to anything. It's more a gate that you need to get through. So that first statement says, unless it's denied in the rest of this policy, you're going to continue on to the next round. But that statement that might make you itchy doesn't actually grant anybody access to do anything. But that second statement is a pretty common statement for service control policies. I sort of parsing this one out to you. It says, we're not going to do anything in S3 unless the bucket belongs to our AWS organization. That kind of makes sense, right? I don't want them exfiltrating data to an S3 bucket that's not under my control, so I write this policy. Okay, so we passed the service control policy because we didn't run afoul of that deny statement because that other account 2 actually is in my same organization. And then we went on to the principal policy, which said, yes, they actually, they are allowed to do get object. So account 1 has said, this request passes, allow. But we're not done, right? We actually need to go on to account 2, right? Because there's 2 issuers here. In account 2, it's a very similar story. Account 2 owns the bucket and therefore has issued this bucket policy. But again, let's make this more interesting. Let's add a resource control policy now that we have this feature. And you'll notice that it's very much shaped like the service control policy we looked at a second ago. You can see that first statement, yeah, we're allowing everything, and that basically means that we're, anything that isn't explicitly denied here this is a gate. And then that second one, well, let's take a look at the second one. The second one has two conditions on it. I'm going to explain those two conditions in just a minute. But the first of these conditions says, unless the principal is from my organization, unless it's someone from within my perimeter, I'm just going to say no. I don't know who's making a request to my bucket, but I don't want them to succeed, right? So that's the important gate here. That means that no matter what's in that bucket policy, we have prevented outsiders from getting into my data. If you're wondering what that principle is AWS service is doing at the bottom, don't worry, I'm going to explain that in just a second. But let me explain to you what just happened. We have an orthogonal control here. This is very, very significant for giving your developers freedom. Because if you remember, at the top, we might have had some org level administrator who really does know what they're doing in IAM. They wrote this resource control policy, and that's in place regardless of what that individual cloud operator at the bottom has written. Perhaps that cloud operator has written a really good, well-scoped policy allowing specifically account 1, and that would be great if he did that. But again, at scale, he may also have written this policy. And because we have this orthogonal control, now I don't know what this policy does because it's literally a scribble. Regardless of what he did, the resource control policy at the top is still in place. Outsiders aren't getting in. Even if he wrote a policy allowing account 666 that is not in my organization, if 666 isn't in my organization, they're not going to be able to get access because of this other orthogonal control. That's the power of this. And what that means is we can have lots of cloud operators and lots of S3 buckets. Hey, S3 recently drastically raised the number of buckets you can have in an account, so we're now talking millions of buckets perhaps. And no matter what is written in the respective policies of all of these buckets, I know that the policy up top is in effect here. I'm going to give you a little bit of practical guidance here on writing resource control policies. These are patterns that we've seen our customers use effectively to just achieve some very sort of common goals here. So we're going to revisit this resource control policy for S3 that we wrote before. And I said, okay, don't allow requesters who are outside my org that aren't AWS services. That's what that second one means. Okay, I'm going to explain this a little bit more. This statement here is denying access from any AWS account owned by someone in the world who's not in my org. And we're excluding AWS. So why do we exclude AWS? Well, the policy statement you just saw here, it's good for these kinds of use cases where you have just a regular AWS account talking to a resource as another regular AWS account. And a lot of access in AWS is in fact shaped that way. Any workload you build is going to look like that. But if you've used AWS, you know there's another pattern of access to your S3 bucket that's out there, and that's the AWS services that are trying to get access to your bucket. A great example is CloudTrail, which you're all running because we're here at a security conference. CloudTrail writes its events into your S3 bucket. You've noticed that you have an S3 bucket with a policy on it allowing cloudtrail.amazonaws.com to write its events into your bucket. You want CloudTrail to access your bucket. Now, of course, CloudTrail is not in your organization. They're an AWS service principal entity. The bucket policy on your S3 bucket for CloudTrail looks about like this. This isn't the full thing with all of the with everything in there. I've got a little QR code if you want to see the page of the documentation where we show you the real one. But the important point here, okay, so the caller is cloudtrail.amazonaws.com, and there's this second thing at the bottom that you're probably noticing called source account. This is an indicator that CloudTrail is acting on behalf of my account, on account 22. So that's what I expect. I do not expect in this account for CloudTrail to be operating on behalf of some other account and writing data to my bucket. So I say that specifically in the policy, and that's in the docs example. You can see it. This is, if you know the jargon here, the security jargon here, it's called confused deputy. This is a confused deputy protection. CloudTrail on behalf of me. Okay, now of course I've got a whole organization full of accounts, all of them with CloudTrail turned on, all of them with the CloudTrail bucket, and I need to make sure that CloudTrail is respectively writing my organization's data to each of these buckets. It's not, again, I want confused deputy protection at scale. And so there's actually a second statement that you would typically put on a resource control policy statement. This one says, so this was the one that we looked at before. Not an AWS service, they better be for my org. This is the other statement that's usually there with it. If they are an AWS service, that might be okay too, but they better be acting on behalf of, you notice this source org ID. They better be acting on behalf of an account in my org. So it's confused deputy protection at scale. So that's how this works. All right, so that is what resource control policies are. That's how they work. Those are some example successful resource control policies that we see customers being successful with out there. And now I want to bring up David, and he's going to tell you how this actually plays out in practice at Comcast. Thank you so much, David.
Thanks, Becky. So as Becky mentioned, my name is David Hockey, and I lead governance and product for AWS at Comcast within our cable group. Today I'm going to give you an overview of our organization, tell you a little bit about how we operate in AWS and our approach to governance. As part of that, I'm going to lead into how we're integrating resource control policies into our journey and tell you a little bit more about what's next. So for those of you who don't know, Comcast, based here in Philadelphia, is a media, entertainment, and telecommunications company that operates building customer experiences globally. Within AWS, we have thousands of accounts and more than 7,500 users, and we operate across tens of regions. Within this, we consume dozens of AWS services across multiple lines of business. So in an organization that's so complex and varied in terms of use cases, how do we think about governance? So we developed a set of guiding principles that really inform the way we think about everything we do. And that's driven by developer experience, the scalability of the solution, operational stability of the solution, and of course, all of that has to be balanced with security. Choice and agility are key to our culture, but this, of course, needs to be balanced with security. To achieve that, we implement a core set of controls, both preventative and detective. I'm going to talk about each of these guiding principles a little bit more. So from a developer experience perspective, we think about things like the ability to deploy and scale quickly, really being flexible in terms of allowing teams to leverage the services and tools that work best for their use case. In terms of integration, we want to make sure that we respect the AWS native SDKs and tooling wherever possible, and we always prefer self-service access over tickets. On the ground floor of this is a DevOps foundation. We want to make sure that anything we're implementing emphasizes automation, infrastructure as code, and CI/CD. So how does the rest of that play in? We take a layered approach to security. On the bottom, we have organizational defaults. You can think of these as things like VPC configuration, IMDS v2, usage, allowed AMIs, and tag standards. On top of that are preventative controls. These tend to be more coarse-grained, things like service control policies and resource control policies. And then above that, we have a set of detective controls. This consists of a series of first and third-party services, as well as custom tooling. And then finally, we have that fine-grained configuration. You can think of this as things like IAM principal and resource-based policies and security groups. All of this forms a shared responsibility model. In the same way, AWS has a shared responsibility model with its customers, being responsible for the security of the cloud. Customers have a responsibility for security in the cloud. And we share that with our users. It's a partnership between our cloud, security, and application teams. So from an operational stability perspective, we look at these organizational defaults and preventative controls, the things that can potentially break things when deployed. And everything we do in this space needs to be scalable to the number of accounts and engineers that we're supporting. These have the largest blast radius and therefore require the largest amount of change control. Above that, we think about detective controls and fine-grained configuration as part of a least privileged journey. Detective controls provide a framework for an iterative approach to least privilege and monitor for things that don't yet have preventative controls. So the natural question you might have is, okay, so with all the different places you can implement controls, how do you decide on the approach? And the way we think about this, or the way I think about this, is sort of on two dimensions. On the bottom, we have sort of the adoption of the service or feature that you're thinking about making a change to, and on the y-axis, we think about sort of the increase in complexity or risk that's associated with making that change. So in the base case, or in perhaps the simplest case, you have a new feature or service. This is where you have the easiest opportunity to act. You can imagine writing a very simple policy like this, deny a given service for all principals and all resources. This is pretty straightforward. What happens as adoption grows? So when you have something like a low use or niche service, there's typically requires modest amount of communication and mitigation overhead to apply changes in this case. You might start with detective controls, or you might take something like a cap and grow approach. So similarly, we're writing now a slightly different policy where we're saying, deny access to a given service for all principals and all resources, except those in, let's say, account 1 and account 3. So in this case, we're capping usage on the current set of accounts, and we're going to grow usage in perhaps a preferred alternative solution. Where things get more complicated is once you hit a critical mass. So this happens most often when AWS introduces new controls, like new preventative controls like resource control policies that we'll be talking about today. In this case, we always start with detective controls, and there's significant trade-offs, planning, and timelines associated with making changes at this point. It becomes much less cut and dry. Now you can see that this deny statement for a given service, it's no longer obvious what principals or resources or sets of accounts we're going to allow when adoption is so proliferated across the organization. So how does this apply to RCPs? Well, so for context, there's a lot of ways you can use RCPs. Our initial approach is really focused on the data perimeter use case that Becky talked about earlier, really thinking about how data enters and leaves our organization. When we looked at a set of resources that are supported by resource control policies, we also know that we use all of these services at significant scale. So alongside this significant new capability that augments detective controls, it has huge potential benefit, but also huge potential impact. There's also some limitations we'll have to be aware of. As I mentioned, there's obviously a very large blast radius. You're limited to 1,000 policies today per organization, so this becomes relevant as you think about potentially writing policies per account. And like service control policies, you're limited to 5 RCPs per entity. An entity is an AWS organization, organizational unit, or account, and you're limited to about 5,000 characters. This is really about as complex as it could get. So what do we do in this scenario? Well, we look at the set of capabilities in our governance toolkit. Today, I'll primarily be focused on these. And really, let's look at how we're going to design and deploy a set of policies. So to help you understand how we're going to do this, it's important for you to understand what our AWS organizational structure looks like today. Today, we have sort of 2 key organizational units, a sandbox organizational unit and a standard organizational unit. The sandbox organizational unit houses accounts for learning and development. They don't contain any production data. They're time-bound and budget-bound. On the other side, we have what we call our standard organizational unit. This is where all other accounts live. You can think non-prod, prod accounts, QA, what have you. We apply the same controls or similar controls to all accounts in this area. And the reason we do that is it really allows our development teams to have confidence that something that they build in a lower environment will successfully promote as they go towards production. This also gives them some more flexibility in terms of what and how they do things or what they store in perhaps lower environments, knowing that they have the same expectations of security controls applied in those environments. The other important thing to note is that this doesn't reflect any sort of business hierarchy, but really policy boundaries, such as regional restrictions. And I'm showing that here as a control organization, two different control organizational units. So using this organizational structure actually really helps us when we think about how are we going to deploy complex changes. When we're thinking about new deployments, we look at a couple things, and we consider things like the risk of change. Are we adding or removing access? As well as the location of the change. Is this a change within an account or an organization-wide change? And based on this, we'll typically do some sort of phased deployment. Generally, we'll start with internal test accounts. These are accounts that are managed by our team that live within our standard organizational unit, where we'll apply those controls perhaps first within the account or on top of the account, depending on the type of change being made. And then once we're confident in the way that policy looks and we're ready to deploy it further, we'll take that first to our sandbox organizational unit. This again emphasizes that pillar of operational stability. We know that changes we make here are unlikely to have any significant organizational impact, as they don't contain any production workloads. This is also the time when we start communications and documentation with our development community. We'll then again focus on new accounts. Again, operational stability, no running resources, very unlikely to break anything. Then we look at things like accounts potentially not using that service or feature that we're impacting. Again, lowest risk. And then as we get into the higher risk categories, we'll proceed typically in waves, looking at things like production versus non-production, as well as impacted resource count. So now that you know how we're going to deploy these policies, what is the actual policy that we're going to deploy? So there's some policy considerations that you need to be aware of, especially if you're coming from a world like we are of deploying service control policies for the last several years. We're generally comfortable with the policy language and syntax and deployment approach, but there's some new differences that we need to be aware of that sort of change the way you think about writing policy. So SCPs apply to principals. This could be a user in your organization, an AWS role, or another AWS service, versus the number of resources in your organization. So for us, we imagine that we have orders of magnitude more resources than we have principals. And this really comes into play when you're thinking about designing for allowances. So if you're thinking about enumerating resources that you're going to allow through this data perimeter, you need to be cognizant of the fact that the number of resources you might need to exempt is likely far more than you've ever had to write in some sort of principal policy like an SCP. Additionally, RCPs apply to both principals inside and outside of your organization, which creates a new testing burden. Previously, with SCPs, you could be really confident that a policy you applied to a principal in your account, in your organization, would exhibit the behavior as any other resource or any other principal in your organization. With RCPs, you have this new dimension where you no longer have visibility, potentially, into the user or role that it's calling into your organization. So there's a few ways to test this. You can either create an additional AWS organization, such as test organization, or leverage an organization from a trusted third party. Or you can apply intra-organizational controls. So in addition to those resource organization ID and source organization ID condition keys that Becky talked about earlier, we also have condition keys called resource OU path and source OU path, which allow you to do things, apply similar data perimeter controls, but across organizational units within your environment. And lastly, going back to that confused deputy case that Becky talked about earlier, where an AWS service is operating on your behalf, it turns out that you also have to make a compatibility versus security decision. Today, not all AWS services support those confused deputy condition keys. So when you're rolling out RCPs, you really have to think about, do I want to take an operationally safe approach and allow all existing services to work seamlessly with my organization? Or do you take a more security-centric approach and say, hey, only services that support these confused deputy keys will be allowed to continue to operate in my organization? So we have a policy that we're going to deploy, and we know what some of the limitations are, but how do we actually determine the impact of applying these new preventative controls? So for us, we turn to an AWS service called IAM Access Analyzer. You probably heard about it a little bit in the keynote this morning. Access Analyzer is integrated with AWS organizations, and it's a regional service. The goal of Access Analyzer, or one of the capabilities of Access Analyzer, is to tell you about all the access that is external to a given AWS account or AWS organization. So what that allows you to do is really understand, okay, who currently has access to resources outside of my account? And to clean up that data, you can use another capability of Access Analyzer called archive rules. This allows you to define well-known exceptions or exclusions, I should say, for well-known federated trusts, things like your single sign-on providers, third-party SaaS products you might deploy pervasively in your organization. And additionally, just as a note, we also defined an archive rule for all IAM resources in everything but one region. Today, Access Analyzer creates findings in every region for IAM. And then we aggregate and analyze the remaining findings using the service APIs as well as custom tooling. There are some limitations to be aware of, though, of Access Analyzer. So currently, it actually doesn't support the confused deputy use case, as it doesn't include service principals like the service that would be used to deliver VPC flow logs to an S3 bucket that you maintain in resource policies. So if you're planning on deploying safely confused deputy controls, you need to leverage other tools, potentially a third-party CSPM or AWS config, to evaluate those resource policies and understand impact. It's also important to note that Access Analyzer is a static analysis. So while it identifies all of that existing external access, it doesn't actually tell you if it's still in use or if it's required. And it supports today only a single zone of trust. And what that means is that it only supports looking at a single AWS account or single organization at a given time. So if you have another AWS organization you expect to allow in your data perimeter, you're going to have to sort of manually pull or programmatically pull the list of accounts from that AWS organization and integrate it into your custom tooling in order to sort of filter out those accounts. Access Analyzer today doesn't cover all services, but it does generally cover all services that you can impact today with RCPs, which makes it a really great tool to use. Another tool you can use to assess impact is AWS CloudTrail. CloudTrail, also integrated with AWS organizations and also regional service, supports centralized event delivery for all activity going on in your AWS accounts. And CloudTrail is really your opportunity to say, like, how do I determine what's really going to break? So the nice thing is that CloudTrail by default and for free logs management events. And so for STS, Secrets Manager, and KMS, basically all management events, control plane events, and data events are actually included in this by default. That being said, there's other resource types that are classified as data events, like S3 object level APIs and SQS message level APIs that come at an additional cost. There's a cost-benefit trade-off for data events, and most organizations likely only enable them for the highest value or risk resources. So CloudTrail may not be able to tell you truly if a resource is in use without potentially significant spend and significant data volume to analyze. So with that, what did things look like prior to RCPs? So prior to RCPs, we can imagine that scenario that Becky showed earlier of an authorized developer looking to provide access to an S3 bucket to a third-party account. And they write that bucket policy. So today we can use things like, or prior to RCPs, we could use things like detective controls to notify that user and confirm, hey, is this access really required? And at that point, they can potentially go change that policy as required. But in the new world, where we've deployed some sort of restrictive resource control policy on top of account 2, when that authorized developer adds a bucket policy to S3, that access is no longer allowed. So what do? So in order to support this in a scalable way, we implemented a self-service process wherein developers can go and declare their intended external access through a portal. It goes through some sort of additional approval logic, and then once that request is approved, we then have automation that'll go and deploy this updated RCP on top of account 2. And you can see now that the combination of these 3 policies have allowed access into the organization. Additionally, this gives us a great data set to understand or a great place to remove access as well when it's no longer required. And we can simply remove access from the resource control policy using that same set of information that we had before. So where are we in this? We've created that external access provisioning process that I just talked about, and we've developed sort of a baseline external access RCP for our organization. We've identified, or we're identifying, existing required external access, and we're utilizing a cap and grow strategy where basically we're going to take all sort of existing required external access, and we're going to put that into account-specific RCPs. And then basically any new access after these deployments happen will have to go through that self-service provisioning process. And we're in the initial rollouts of this now. What's next? So we're going to continue deployments. We need to fully automate that allow listing process. Today, there's still sort of a manual step between a request being approved and then that RCP getting updated. We're planning to fully automate that end-to-end so that development teams have sort of a fully self-service experience. We know that we have to iterate on this approach and be cognizant of the limits. As I mentioned before, we already have more than 1,000 accounts, so we have to really be cognizant of the fact that there are these limits, and we have to be aware of where and how external access is required. And then we're starting to look at, as AWS makes new service available with RCPs, how would we safely roll those out on top? So with that, I'm going to turn it back to Becky to wrap things up and talk about additional resources available to you so you can do this in your organization.
Wow, thank you so much, David. Hopefully you were all taking notes, because this is what builders, particularly builders at large enterprise organizations, need to know in order to be able to effectively roll out these wide impact kind of changes to establish this perimeter. So now's the time when you should take out your phones, because I got some QR codes for you that are going to save you a lot of time. All right. So here we have, this is our white paper on building a data perimeter at AWS. If this sounds like something you want to do, and it probably is, to keep your data inside your organization, keep outsiders out of your data, and other considerations that I didn't talk about today, like network-based data perimeter rules. And you don't know where to start with this white paper. Kind of explains the concepts and then gives you a further kind of prescriptive advice on how to proceed. Take a picture of this one too. We have a GitHub repo. That gives you, it's basically your cheat sheet. We give you the copy pasta here, right? Like these are the policies that we recommend that you put in place to establish a data perimeter. So no guessing. This isn't your high school physics class. We gave you the right answers. Also, very recently in this repository, we've also added some, for an initial set of services, 20-something of them, we've added some service-specific guidance that kind of takes you through anything special you need to, from a data perimeter perspective, that you should be thinking about as you're using that service. So you no longer need to study them yourselves. We studied it. We put it up there for you. So I hope you have a great rest of your conference here at Reinforce in Philadelphia. And David and I would love to take your questions. If you have hard questions, they're for David. We're going to take, just out of consideration of the expo hall, hall here, we're going to take them out in the expo just back there. So if you're trying to ask us a question, we'll see you out there in just a minute or two. So thank you so much for coming. Have a great rest of your conference. Have a great time here in Philadelphia.